Hello, everyone, and welcome to today's Tech Talk series. Today, we're going to be having a comparative discussion of running the Oracle database in the cloud. My name is Eddie Ambler, and my co-host today is...
And I'm Leo Alvarado.
We're excited that you decided to spend your lunch hour with us to go over this interesting topic. In today's Tech Talk agenda, we will be introducing the Oracle Converged database, reviewing the OCI footprint and the available services, introducing you to the available Oracle database cloud services, discussing the billing and licensing models that you can use as you move into the cloud, and going over the cloud management responsibilities as you make decisions on your deployment choices for your Oracle database, whether you're going to run them on IaaS, PaaS, or consume one of the fully managed DBaaS services. We'll then jump into a database capacity cost comparison, where we'll look at how we would position co-managed solutions such as the base database and the Exadata database on Oracle Cloud. And then we'll also look at how the Oracle database actually it can be positioned by looking at the base database versus the custom Oracle RDS. And we'll look at a few fully managed options as well. That way you are able to understand from a scale perspective where the Oracle Cloud database services fit and how our scale also compares to the competition. So let's start by going over the Oracle database, right? The great thing about the Oracle database, which many of our users still do not really realize, is that it is full of all of the modern point solution database data models that are offered as separate databases by our competitors. It is provided in one converged design where from a single SQL statement be able to access data that's in spatial, that's in graph, that's in JSON, that's in XML, and be able to produce that information out of that data that you need in a uniform and secured way. So by having an all-inclusive and converged design, we really do enable our developers to be able to define and produce the world's best modern applications that are designed to scale, perform, and be secure. You know, the converged Oracle database, where is it? It's available everywhere. It doesn't matter if you are running the Oracle database on-premise, on one of our engineered systems, on commodity hardware, or in the cloud on our engineered systems, or maybe on our IaaS cloud service offerings, or if you're running it on third-party clouds, or in your data center using our engineered systems with things like our Cloud at Customer. So by having the same Oracle database engine be available independent of your deployment model, what that brings to the table is your ability to build an end-to-end cloud solution and to build a hybrid cloud solution and a multi-cloud solution without having to make changes to your code just because you've made a change in your deployment model. So where is Oracle Cloud available? You know, Oracle has been busy building cloud regions around the world. We currently have 44 regions with 7 more planned, and 12 of our regions are already Azure Interconnect regions. You know, Oracle has been in the forefront in, building an open cloud that is very amenable to the multi-cloud technology, given our customers' choice. So this, again, just like our database services, allows you to be able to build a hybrid cloud and a multi-cloud without any needs for changing your database just because you've decided on its deployment model. So what are the available cloud services? This is an area where many people are not really aware of all what's available in Oracle Cloud. Oracle Cloud has got all of the standard IaaS that you would expect: compute, network storage, containers, OS images that you would like to build on, all the networking elements you would use to build. It has a whole suite of tools and applications for the developers so that they can carry out their modern DevOps practices, build low-code applications by leveraging things such as the Apex code engines that we have. They're able to interface with their standard development tools that they have. The developers want to build modern applications. So whether they're looking to build serverless applications, integrate applications across each other, or just leverage Oracle's SaaS services, right? Oracle's suite of SaaS services are available in the cloud for consumption. And all of these services have some level of analytics already built in and pre-integrated, so you can get a jump start on having a more unified view of your data as you continue to build out. And no cloud would really be a good cloud if it wasn't secure. At the heart of all of the elements that we do, we include security and governance, and we provide the tools to give you observability, right? So that you can be able to see what is going on, audit what's going on, and use the automated tools to monitor, notify, and even take proactive actions. And as I mentioned, we are building the cloud with good governance and standards so that it's easily can extend beyond your data center, beyond the Oracle Cloud, and include multi-cloud solutions as well. At the heart of the OCI services is our data management layer. We have tools to help with data movement, data migration, data processing, and we have a suite of Oracle database services that you can take advantage of to give you just the exact data model you need without needing to deploy a bunch of different databases and constantly be moving and transforming data. So let's focus in a little bit on the Oracle Database Cloud Services. In the cloud, the Oracle database can be run, as I mentioned, as a cloud service in the public cloud or in your data center. So we have a suite of database services here. Our base database service, it runs on our shared VM infrastructure. It can service database sizes up to about 80 terabytes and can run single instance or 2-node racks. And can service IOPS workloads that reach upwards of 1 million IOPS in a 2-node rack configuration. So lots of capabilities there. And for those workloads that need a little bit more capacity than the base database service offers, they can run one of our Exadata database service deployments, which will give them the capacity of the underlying Exadata cloud infrastructure platform. So with the Exadata database service, you can run it in the public cloud on dedicated infrastructure. And also in the public cloud, if you need a fully managed service, then we have the autonomous database, which can be run on shared and dedicated Exadata infrastructure. And for those of you who really need to keep your data behind your firewall in your data center, we also have the Exadata database service that runs on Cloud at Customer and the autonomous database that runs on Exadata Cloud at Customer as well. So the biggest difference to outline is that the Exadata database service and the base database service are considered co-managed services in which Oracle manages the infrastructure up to the hypervisor, and the customer will manage the database above that. With the autonomous database, Oracle will manage the entire stack. You just worry about your business requirements and the data itself. One of the really cool features that the Oracle Public Cloud brings for the Oracle Database Services is that there's no minimum term. So on-premise, you might have needed to worry about planning for a huge capital expenditure, committing to a solution for many, many years. In the public cloud, you can simply spin up the infrastructure with as little as a 48-hour commitment. And beyond that, you only pay for the OCP and storage that you need. So when you're done with it, you spin it down and you're done. So it makes it very easy to prototype things, very affordable to run your workloads using cloud economics. So with that, let's talk about billing and licensing models for the Oracle Database Cloud Services. So there basically are two choices of licensing models that can generate maximum value for you. The first one is your bring your own license, right? It's ideal for organizations that are moving existing workloads with consistent usage to the cloud. It allows you to utilize your on-premise licenses and save on your existing software support costs. When you bring your license, also known as BYOL, to the cloud, What you get is your transparent data encryption, because again, we want every data to be secure. So although on premise you would have to buy TDE as a separate license, when you bring your own Enterprise Edition license to the cloud, TDE is included. You also get data safe, Oracle machine learning, and select management packs at no additional cost. The next model is license included. This is ideal for organizations seeking to build new applications with dynamic utilization, right? It includes all the Oracle database options, management packs at one low price, right? This gives you the pay-per-use pricing for OCPUs that are all paid for with universal credits. What this means is that you no longer have to say, I need, 10 units of one particular database service and 15 units of another database service, and you're trying to align that complex service needs. In the cloud, you literally are able to, with license included, use all the packs and only pay for the OCPUs that you have enabled. So if your workload needs more CPU today, you increase you scale up the OCPUs to match the workload demand. When that demand falls off, you lower the OCPUs, and what that brings to you is a cost savings that you can bring to the business, because then you no longer have to operate your model at peak capacity. You literally can dynamically map your enabled OCPUs to the workload demand.
Eddie, I have a question here.
Yeah.
Can I run Oracle Standard Edition for BaseDB with license included?
Yes. So in the Oracle Cloud, the base database service actually has access to 4 tiers of licensing. So I was just getting ready to actually talk about that. So the first tier is Standard Edition 2. This gives you your basics, right? Starting with security right at the top. It gives you the ability to use multi-tenant with up to 3 PDBs for the container database, machine learning, spatial, and graph. The next tier of licensing is the Enterprise Edition, which then brings to the table data guard, real application testing, data masking, and subsetting packs. And it also gives you access to tuning pack and diagnostic packs. The third tier gives you the Enterprise Edition, what is called high performance. This is where we introduce features such as partitioning a multi-tenant, advanced compression, advanced security, and the lifecycle and cloud management packs. So all of these tiers build on top of each other. So as you're building up your tiers, everything that you had in the standard tier and enterprise tier, and now the high performance, those are cumulative. So the Enterprise Edition Extreme Performance is our final tier that brings to bear the features such as active data guard, real application clusters, application continuity, and database in memory. The thing to note here is that base database service, when it's configured with 2-node rack, and the Exadata database service actually both use the Enterprise Edition Extreme Performance. So they are entitled, with license included in that particular SKU, to be able to use all of the database options. So hopefully, Leo, I was able to answer your question, is that the base database has not just the ability to use Standard Edition, but any of these editions that meet their particular applications needs.
Well, yeah, thanks, Eddie. And then does the license included for the BaseDB and ExaDB services include the cost for storage?
Great question. They do not. So license included is just giving you the OCPU and the database software license in it. Okay. The storage costs will be determined by the service that you pick. And we will actually go through that in our examples so that you get a good visual of how these service price points come to bear.
But in the cloud, do we also need to license the Exadata storage software?
Great question. And the answer is no, right? So if you were used to paying for the Exadata platform on premise, it had an infrastructure charge, and it had a database license charge, and it also had an Exadata store server software charge. So in the cloud, that goes away, right? So when you do license included or BYOL for the Exadata database service, the storage software license included in both of those models. So Thanks for asking that. It's a great way to, right out of the box, improve your ROI. So let's take a look at the cloud management responsibilities for the Oracle Cloud Database Solutions, right? So that you can get an understanding of how things roll out. So, OCI frees customer resources to be able to do higher value initiatives, right? It allows us to lower costs, it allows us to enable self-service, and it removes the management burden of IT having do-it-yourself model. So traditionally, if you were on premise, you would manage the whole stack. In the cloud, if you were to get IaaS, meaning a VM that is managed by the Oracle, right, then you would still have to deploy all of the database software, manage all of the database environment, the OS environment, and all those things. So pretty much like a DIY, do-it-yourself experience is what you would get if you tried to run the Oracle database on IaaS. Our PaaS services, right, which we mentioned earlier, the base database known as BaseDB and the Exadata database service known as ExaDB, it starts to shift some of that infrastructure management that you have to do to Oracle. So you can see on our line there in the middle, Oracle manages the infrastructure up to the hypervisor, but that's not where we stop. We actually then also deliver cloud automation tools for many of those tasks that you have to do that manage, such as monitoring and tuning, backup and restore, patching and upgrades. All of those things, we give you the automation tools to make even those tasks easier for you so that you can just simply execute them through one of the management interfaces. Now, for those customers who are looking for a fully managed database experience, the far right side, you see ADB, which is the acronym for Autonomous Database. This gives you the fully managed database experience where Oracle manages the entire stack, right? You manage your data in your applications. This gives you additional time for you to focus more on more important parts of your business, right? Making sure that you're delivering value to the business instead of worrying about having to manage the infrastructure. So let's get into it, right? Let's have our first discussion here really around our base database service and our Exadata database service. How does the capacity cost comparison start to look when we take a look at the base database service with a 2-node rack configuration? So what I wanted to do here is first just kind of set up the scenario. Throughout all the comparisons, we're going to use the very same set of requirements, right? We're going to be trying to service a workload that has 64 CPUs. Other cloud vendors, they might refer to vCPUs. So I've listed the fact that 64 CPUs is the same as 128 vCPUs. And that compute is going to have 1 terabyte of RAM as the requirement. We're going to be using license included for this comparison with the extreme performance for the CPU cost. The interesting thing is that then actually we'll have 64 terabytes of usable storage as our requirement. This is when I say usable storage, this is the requirement for data and Rico space together, okay? Now, on the next service, the Exadata database service, which is going to be a quarter rack, which has 2 nodes in it, we're going to be looking at an X9M configuration, which gives us 256 OCPU and 190 terabytes in its shape. But our requirements for the workload are still just 64 CPUs, 64 terabytes of storage.
Hey Eddie, I see here that the license included OCPU per hour cost is the same for BaseDB and ExaDB. So is it really the same for both services?
I'm glad you caught that. The answer is yes. And so what that allows us to do is you'll see in our comparisons, right? If the cost of the OCPUs are going to be exactly the same, then the thing that's going to drive the cost is going to be the difference in the storage. So as we go through the comparisons, we will show you at what point it makes sense to run base database storage versus the Exadata database storage based on capacity. And we'll also outline, where you would pick up extra CPUs because of the shapes. So let's jump into it. So we'll start by just simply graphing the base database service using higher performance storage. So the smallest BaseDB storage allocation that I can do is 512 gigabytes, right? This is 256 gigabytes for data and 256 gigabytes for the Rico space. And as you can see, it's a whopping $30 a month to run that size of database on the base database system for the storage. Okay. We're going to focus on storage for these comparisons because we've already established that the OCPUs with license included are going to be an exact same cost for both services. So the next thing that you'll notice, right, is that our base database service can actually go all the way to 100 terabytes usable, which means that it will have 80 terabytes of data storage and 20 terabytes of Rico storage. So we'll be able to run a database, a single database that needs 80 terabytes of data space and 20 terabytes of Rico space in a base database system for a cost of $6,093 for the storage. As you increase your storage size, your storage cost will go up appropriately from as little as $30 to the $6,093 mark.
Eddie, can I scale the base DB storage for data and Rico independently?
I'm glad you asked. So the answer is going to be yes. So when you start out, remember I mentioned that the smallest base DB storage evenly divides that 512 gigabytes between data and storage. You can then come back using any of the management interfaces, the UI or the API or the command line interfaces, right? Or to issue the scale storage command, which will then give you the ability to say that you want to scale just the data disk group or just the Rico disk group or both. So you can scale them independently after the initial allocations.
Great. Thanks, Eddie. So now I have another question. So for base DB, how many OCPUs can I scale?
So BaseDB, again, can have 64 OCPUs on each compute nodes, and it has the ability to run in single instance or in two-node rack configuration. So if it's in a two-node rack configuration, you'll be able to run up to 128 OCPUs for this particular service while still addressing the 100 terabytes of usable storage. It's a great question. All right. So, we've been talking about the base database, and you were asking some scaling questions. So this actually leads us to this next slide here, which really outlines in this purple area that once you need more scale or performance than the base database offers, the next tier up is that you'll need to consider one of the Exadata database services that are running on the Exadata Cloud Infrastructure platform. In the purple, we are showing the Exadata database service base system, which is a fixed configuration system, right? You will note that it actually has a little less physical storage, max usable storage than the base database did, right? It has 74 terabytes of usable data, whereas the base database had 100. But what makes this particular offering attractive is that it has a tiered storage system that uses NVMe, flash, and hard disk to give you superior performance and scale that also provides Exadata storage server software and CPUs down in those storage servers that do work for the compute. So you're able to actually, for those workloads that can fit in that space, be able to give superior performance at the lowest entry cost point for the Exadata database service. So at the very top, you see another Exadata configuration, which is the Exadata database service quarter rack elastic configuration. And the reason it's the elastic is this is the starting point of the service, and you are able to scale this service above the quarter rack capacity by adding compute and storage independently to get just the resources you need. Okay, so you can see that our green line goes all the way out to 190 terabytes of storage that's included in that $10,800 price point, right? So when you buy your Exadata system, you're not paying for the storage in increments of 1 gig, you're paying them in increments of the storage server. So if you need more storage, you simply can just add additional storage servers to get to whatever number you need. As you add those storage servers, your performance and your scale grow linearly. That part of the conversation then brings a very interesting one that I wanted to outline, is that as you look at your organization's demand for storage, once you approach 175 terabytes of storage capacity demand, you'll notice that the price of storage for 175 terabytes for base database and Exadata database service comes out to be the same value. And remember, the OCPU component, again, right, costs you the same. So what you'll be able to do then is be able to start to ask yourself questions. If I have a small database that needs the Exadata performance, I might still need to actually put that database into one of my Exadata platform choices. So for example, the 40 terabyte database example that I had on the screen, I could service it on the base database system for $2,440 a month if I were to run it in the base database service. But maybe that service doesn't give me the performance I need. Then I'd have to decide, do I have enough other workloads that could warrant me going into the Exadata database base model that's in the purple at $7,850 a month? Or maybe I have even more than 74 terabytes worth of other workloads that I want to consolidate, and I'm going to start my consolidation by using the Elastic infrastructure at 10.8. So a little bit of discussions need to happen where you're trying to figure out not just this one database, but how much overall storage would I need to service all my other workloads so that you can get the best value out of your Exadata platform.
Then what can I do with all of the space and OCPUs that my database doesn't need?
Okay. Well, that's great, because looking at this slide here, you could see that your Exadata database service in the public cloud has 190 terabytes of space available, and in the cloud at customer, we've got 240 terabytes of space available just in the quarter rack configuration. So lots of space. So what can we do with it? Right? It's like I was saying, we can develop a consolidation practice, right? Consolidate databases onto excess Exadata resources for less than the base database license included, right? Because you've already paid for the Exadata capacity, there's no additional cost to use those storage. And because the licensing for the OCPUs are exactly the same, then it costs you less to run the additional databases on that storage. So the purple line is showing you that if we were to put our 40 terabyte database on a base database system, we would actually have the rest of that, the capacity above 40 terabytes to 74 terabytes to run other workloads. Same thing if we were on the Exadata database service quarter rack, we would be able to use almost another 150 terabytes of storage to run other databases at no additional cost. So as you can see, my ROI just gets better and better. And the more databases I put on here, the cheaper per database it actually is. And by the way, all of those databases are getting that additional performance that the Exadata database service brings to the table. And finally, again, whether I'm running the Exadata database service in the public cloud or in cloud at customer, the consolidation value story is exactly the same. So you're probably wondering, well, why does the cloud at customer version of the Exadata database service have a more storage being displayed? Well, that's because at this point, we are starting to roll out the next generation of our Exadata database platform, and we've started with our Cloud at Customer. So the next generation Exadata X10M Cloud at Customer actually features larger 22 terabyte drives and a host of other items, which will encourage you to visit our next Tech Talk where we do that deep dive to provide you that additional storage at no additional cost. So again, consolidation just continues to improve the ROI. And you can see by the price points on the left, it's not a very hefty uplift. People used to think that the Exadata database service was very expensive, but when you lay it out and you start to compare the capacity points, you can see with consolidation really bring a lot of value to your organization. Now, let's have another conversation. So I've positioned for you, price point capacity wise, where the Oracle database services in the cloud, in the Oracle cloud fit. But what about when you're running the Oracle database on other clouds? So we're going to look at AWS RDS for Oracle and AWS RDS custom for Oracle. Okay, so let's start by going over the management comparison to the Oracle Cloud Database Services. So before I jump into that, let me give you a quick rundown of what this is. So the AWS RDS custom for Oracle is a co-managed solution, right, that provides you a single instance VM with up to 64 CPUs, right, 64 terabytes of elastic block storage, and all the deployments for Enterprise Edition require you to use BYOL. Okay, they do not offer a license included model like we have in the Oracle Cloud. So the customers that want to use this deployment will always have to go buy licenses and then use those licenses in the cloud. Okay, the AWS RDS for Oracle, right, is a fully managed database service that AWS offers. It has got the same infrastructure configuration, right? Single instance VM with up to 64 CPUs. It also offers 64 terabytes of storage and has the requirement for all the Enterprise Edition deployments to use BYOL. So that kind of level sets there. And hopefully you also caught on to the fact that I'm using the same sizing requirements, right? 64 CPUs, 64 terabytes of storage. And the reason that 64 terabytes of storage was what I chose is this is the maximum that the AWS Oracle cloud offerings can address at the moment. Obviously, in the OCI cloud, when we showed the Oracle database services, we were able to extend beyond that 64 terabyte limit. Okay, so let's look at it here. So similar comparison as we saw, if you were on premise, right, you would have to manage everything all by yourself, the whole stack. If we go to the right side and look at the IaaS column, this is where you'll hear the term EC2, right? This is an IaaS VM that is given to you. You, the customer, are responsible for everything on top of that hardware, right? AWS manages the hardware, you manage everything else. Okay, very similar to how we would, in the Oracle Cloud, we had IaaS, we give you a VM and you would be able to do the same thing. So very equivalent type of user experience there. The RDS custom, it fits on what I call PaaS, IaaS Plus. And it is, like I said, a co-managed solution. You do have access to the VM like our BaseDB and our ExaDB offerings in the cloud. You'll see the limitations in capacity and scale coming up in a minute. For the next service, RDS for Oracle, that's the fully managed. So you'll see that I've mapped that service comparatively to our autonomous database serverless offering and our autonomous database dedicated offering, which runs on top of the Exadata database cloud infrastructure platform. Okay, so these our autonomous services have significantly more scale and feature functions than the RDS for Oracle does, but they're both fully managed services. So we'll actually jump into that. So let's look at this capacity cost comparison. So the use case definition doesn't vary. So the first one that we're going to do is we're going to compare our base database single instance with BYOL to the AWS RDS custom. It is co-managed service, just like base database. AWS has got a set of fixed image shapes, and the class of database that we're going to use is the R6i. It is one of their more recent shapes, and it provides the 64 OCPUs and the 1 terabyte of RAM. If you're ever doing a comparison and you need larger memory footprints, there is one other class of servers that AWS offers that has memory footprints that are larger. But from an OCPU perspective, this is a perfect comparison, apples for apples here. So you'll see that there is, for storage, on the AWS RDS custom, I have two line items. There is a GP2 storage that actually has 64 terabytes of capacity available to it, and it is able to produce 80,000 IOs per second. The IO1 type storage, it actually has the ability to also address 64 terabytes, but it has the ability to use what they call provisioned IOPS and give you 256,000 IOPS in that configuration. Now, our base database, right, to just give you some perspective, it is able to produce 640,000 IOPS on its 64 terabytes of storage on a single instance. And remember, it has the ability to run two instances, so it can extend that IOPS capability all the way to 1 million IOPS. So you can quickly see that the base database is able to give you a little bit more room for capacity, throughput, and bandwidth. So again, these are co-managed solutions. The OCPU per hour costs between the two. It costs 20% more for AWS RDS Custom. The usable storage per month for that 64 terabytes costs 93% more for AWS RDS. And if you need the IOPS and you go for IO1 for your storage type, then that's going to cost you 298% more for that solution. So, we were going to look at the price point. So again, our base database, right, with our 100 terabytes of usable storage, it costs $6,093 to be able to use that storage all up. If I needed to, remember our requirement was to get 64 terabytes, which is the max storage for GP2 and IO1. If I went with the GP2 storage type, right, on AWS, that same storage amount would cost me $75.37. And if I went with IO1 storage, which gives me the enhanced IOPS of 256,000, then I would be having to pay $15,537 a month for the same thing. So the point here is that the base database service provides more storage and compute, right, scale at a lower price point, right, along with the additional IOPS that I mentioned there in the configurations. So, I'm not going to spend the time here, but when we post the deck, we went ahead and I just wanted everyone to be aware, these numbers that I'm sharing, they come straight off of the public calculator. So the Oracle has got a public cost calculator that allows us to generate the costs, and AWS has the same type of calculator. So the only thing I will notate here for you is when you are on the Oracle calculator and you put the total available storage that you want, Oracle is referring to the data storage only in that column. They then, down in the storage block volume, will add 20% to that storage to come up with the total usable storage and bill you on that. So I just went ahead and made sure that you were aware of that. So if you wanted 64 terabytes of usable storage, right, you would pick the closest value we could get, which is this 49,152 gigabytes, and that produces a total usable in the calculator of 6164. So this estimate is not quite 64, but this is as close as the calculator gets. But just a little nuance so that you can figure out how to use this. So this is what the AWS estimator looks like. You can see here for our comparisons, we put in the database shape, DBR6i 32X large. which gave us 64 CPU, 128 vCPU, the terabyte of memory we asked for. We're using single AZ, right, as for the comparison, so that if you want a standby, you can add that, but this is just talking about a single deployment. And for the storage, right, you can see we've selected GP2. We've put in our 64 terabyte as the storage amount. And right there in their own calculations, it confirms the monthly storage cost that we said. I said 7,537 in my estimate, just a little rounding, but there you go. So you can use these to confirm. We did the same thing for IO1. You can see that IO1, at the very bottom in the storage section, it shows provisioning IOPS of 80,000. Now that's something I want to just reiterate. With GP2, you have a max of 80,000 IOPS. With IO1 on custom, RDS custom, you're limited to 80,000, but on RDS for Oracle, which is the fully managed version, you actually get 256,000 IOPS. So a little bit more out of that configuration.
Then can I get a license included for Oracle Enterprise from AWS?
No, AWS does not offer license included, right, for enterprise, which is why I was saying you have to do BYOL. If you're going to run enterprise, any one of the enterprise edition services or database features on AWS, you're going to need to do BYOL. So let's look at the autonomous database, right? The fully managed service. I told you we're going to look at, we were just talking about co-managed. Let's look at this fully managed. So the autonomous database runs on top of the Exadata cloud infrastructure platform, right? Whether we're doing a serverless model or we're going to be doing a dedicated infrastructure model. Same sets of requirements are applied in this comparison: 64 CPUs, 64 terabytes of usable storage. So here, when you look at AWS RDS, you see that it's a fully managed solution. The BYOL for CPUs, for the OCPUs, actually come out a little bit less for AWS RDS in this particular scenario. But if you don't really need high performance, right, if you can live with the GP2 64 terabyte and 80K IOPS limit, then the cost of the storage is about the same. But if you need a performant environment that gives you the capacity of IO1 with 256K provisioned IOPS, right? This is where you'll pay a whole lot more for AWS RDS, right? It'll cost you 348% more for that storage to try to achieve the performance that you can get out of the autonomous database serverless. So the autonomous database serverless has a lot more scale and performance capabilities. So when you get to the point that you have a workload that can leverage that, you can see here that it becomes very easy as to which solution it is. So RDS with GP2 and autonomous database serverless, they have about the same storage costs at 64 terabytes, right? 7537. But as soon as you need more performance, right, that cost jumps up to over $33,000 a month for that service. So you can see that autonomous database service really provides more storage and compute scale at a lower price point versus RDS IO1. And the other thing with the ADB-S is that it scales to 128 OCPUs and 128 terabytes out of the box. But if you need even more scale than that, you can simply file a request and get more capacity.
Eddie, since you mentioned the scale, that's a very good point. I have a question, like what's the smallest database OCPU count that I can deploy with ADB serverless?
Wow. Well, you know what? I'm glad you asked. ADB serverless makes it like super affordable for developers to use the environment and take advantage of all the performance. You get fractional OCPUs, as little as a tenth of an OCPU can be allocated to an environment that you're spinning up. So yeah, your starting point with Autonomous Database Serverless from an OCPU perspective can be as little as 1/10 of an OCPU. So thanks for asking that. So again, I provided the proof points of what the cost is for autonomous database with BYOL, the same calculators for what does the storage cost with GP2. You can see that right here, right in their calculator, it tells you that 64 terabytes for the month costs you $7,536.64. So that aligns with the number that we used in our analysis. And then also for the IO1, same thing. You can see at the bottom of the screen here that the storage, right, pricing monthly for IO1 with 256,000 IOPS for the 64 terabytes is priced at $33,792. So these proof points are here just in case someone wants to be able to reproduce it. It's the public calculators, nothing private here. So the very last one we do is, what if we need dedicated, right? What if we don't want the serverless autonomous? We're looking for a fully available system that's on dedicated infrastructure that gives us a little bit more scale. So this is a fully managed solution, right? Autonomous Database Dedicated versus the Autonomous RDS for Oracle. The BYOL OCPU we talked about, and the difference in GP2 and IO1 doesn't change because it's the same AWS. But let's look at it on the graph. Okay, so what you get here, and the graph makes it a little bit easier to see, is that the storage cost for RDS GP2 for 64 terabytes is $77.37. So it's a little bit less than our quarter racks storage capacity of 10,800. But not only our user requirement was for 64 terabytes, but that shape actually it gives us 190 terabytes. So it's not that you're paying $10,800 for 64 terabytes as with GP2. You're actually getting the 190. We talked about, well, what do I do with all that other space, right? This is where you can put other workloads to use that storage at no additional cost. So consolidation will actually make this an even cheaper solution per database. And you still have the same problem with RDS IO1's cost when you need IOPS, right? Because Autonomous is running on the Exadata platform, unlike Base Database, which was kind of reaching 1 million IOPS, we're going to be talking about several millions of IOPS, to read and write in capacity that you're going to get. So we can take a look at the capabilities of the Exadata platform to kind of get it. So ADB-D provides more storage and compute scale at a lower price point versus the RDS IO1. It is able to scale to 256 OCPU and 190 terabytes out of the box. This is using our minimum sized ADB elastic configuration. Leo, any other questions here?
How do I pay for the infrastructure that supports my ADB dedicated?
Autonomous Database Dedicated, ADB-D, right? It actually is a service that resides on top of the Exadata cloud infrastructure in the public cloud, right? You can also run it autonomous, but here in the public cloud, you actually pay for it based on the number of hours that you run the service. So when you see that 10,800, what that represents is 730 hours per month of running, which is essentially running the system 24 hours a day, 30.4 hours, right? 30.4 days per month, right, is what it comes out to. So basically you're running it 24/7.
That's great to know that there's a per hour SKU for the infrastructure that includes the storage. Then I see a value for IOPS here. So does ADB-D have more IOPS than AWS RDS?
All of our services with the storage configurations we did had more IOPS available. The base database, single node server node with 64 terabytes could address 64,000 IOPS. Our Exadata quarter rack again has over 5 million IOPS that it can do. And we can pull the data sheet to show.
Mm.
So the short answer is they not only have more, they have significantly more IOPS and throughput and significantly more storage scale, right? And so above and beyond this, right? We're just talking about what we can do with the quarter rack. But remember, if we needed more space, we can elastically just grow the
Yeah.
storage and the compute. So the value proposition of the solution continues to grow. Whereas with the AWS solutions that are here, you're actually out of resources. There's not an expansion for it. 64 terabytes is the most you can get. Single instance is the most you can get. So once you've exhausted those resources, you then have to re-architect and re-engineer your entire application in order to try and make it work. So again, we had our proof points here. It's the public calculators. You can just go and reproduce all the numbers we produced. We grabbed them all from the public calculator. We've been answering the Q&A as we've been going along. So I know we're tight on time, but I wanted to let you know where you can find resources. So Leo, if you can just take us through in 2 minutes the next set of slides here as we tell them how to they can keep informed, that'd be great.
Okay, so if you want to find more resources about database cloud services, so we have a public Slack workspace. The name is Exadata-database-service. And this is where we publish all our get started guides, how-to demos. We also update the replays for our Tech Talk series and also share some of the technical featured blogs about our database cloud services. And then, yeah, so we invite everyone. So join us with the discussion, anything about database cloud services. So you can also post your questions on our Slack channel. So this is how you join. So just click on the join link, log in your email account for Slack, check your email, configure your 2FA, and that's it. Welcome to our Slack workspace.
All right. I'd like to thank everyone again for their time today. Hopefully you enjoyed the session. Hopefully you found value in the discussion we had. Again, my name is Eddie Ambler and my co-host is.
And I'm Leo Alvarado.
Until we see you next time. Thank you.